Hey everyone, and welcome back to The Explainer. Okay, today we are uncovering something absolutely wild, the invisible architecture of our modern world. Think about every single digital interaction you've had today. Just pause and really think about it. It is entirely possible that every last one of them was silently orchestrated by a technology you interact with constantly, but, might never actually see. Our dependence on this hidden architecture is just absolute.
Which brings us to a huge question. What powers the internet, your smartphone, and space exploration? I know, it sounds like the setup to a joke or a riddle, right? But it's this incredibly dramatic contrast. The everyday miracles we totally take for granted, from scrolling social media on the couch to simulating actual rocket launches at NASA, they're all being run by a hidden giant, operating completely quietly behind the scenes.
Okay, let's dive into this. The answer is Linux. We are talking about a staggering invisible ecosystem. It runs Android smartphones, which literally translates to billions of devices sitting in pockets all over the globe right now. It's the absolute backbone of colossal cloud platforms, meaning every single time you search Google, buy something on Amazon, or scroll through Meta, you are directly interacting with it. It's even running nearly all of the top supercomputers worldwide. Seriously. Before we even get into what it actually is, it's just vital to grasp how massive and foundational this technology's footprint is today. To understand how we got here, we kind of have to flash back to the computing world before Linux even existed. So picture 1969. At Bell Labs, UNIX was created. This introduced revolutionary concepts like multi-user support and hierarchical file systems, basically laying the conceptual foundation for everything. Then jump forward to 1983. A programmer named Richard Stallman begins the GNU Project, and his goal was to build a completely free Unix-like system. And they built some absolutely amazing tools: compilers, command line utilities, shell interfaces, but they hit a massive roadblock. They had essentially built this beautiful, pristine car, but they were missing the engine to actually make it run. Now, you have to remember, in the 1980s, the computing world was mostly locked tight behind closed doors. It was totally dominated by systems that were incredibly expensive, heavily restricted, and completely proprietary. You couldn't just peek under the hood to see how the software worked, let alone tweak it to suit your needs. No way. But contrast that with the open source philosophy that was slowly brewing at the time. Thanks to something called the GNU General Public License, or GPL, this revolutionary collaborative ethos was born. Think of the GPL like a strict but totally brilliant rule. If you improved the code, you had to share your homework with everyone else. It made sure the software stayed free to distribute and modify forever. Which brings us to the pure, beautiful irony of this moment. Listen to this quote: "I'm doing a free operating system, just a hobby." Compare that massive understatement to the flashy multi-million-dollar corporate software launches of the era. In August of 1991, a 21-year-old University of Helsinki student named Linus Torvalds casually posted this famously low-key message to a Usenet newsgroup. He'd been using an educational system called UNIX, but he just wanted better performance and more control over his own PC. To him, this was just a tiny, fun, personal project. He had absolutely no idea that this little hobby was about to change the entire world. So the crucial point is, what Linus actually built was a kernel. Now, if you're wondering what that is, think of a kernel like the incredibly efficient air traffic controller of your computer. It's the very core component that decides which application gets memory, it manages processor time, and it handles all the hardware communication. Linus's kernel was exactly that missing engine that the GNU Project tools were waiting for. Put them together, the Linux kernel and the GNU software tools, and boom, you suddenly had a complete, fully usable operating system officially known as GNU/Linux.
10,000. That's about the number of lines of code in the very first release, Linux 0.01, back in September 1991. To put that into perspective for you, a modern Linux kernel has over 30 million lines. So back then, it was absolutely tiny. It had super basic file system support and minimal hardware compatibility, literally only supporting the Intel 8386 processor. And just booting it up, that required some serious advanced technical knowledge. It was not for the faint of heart.
Because honestly, early Linux wasn't exactly welcoming. There was no mouse to click, no intuitive icons, no colorful desktop backgrounds. It required intense manual configuration and some serious command line expertise. It was essentially a blank canvas waiting for typed instructions, a system built entirely by developers for developers. And while it was undeniably powerful, if you were just an average computer user looking to type up a document or play a quick game, you were basically staring at a daunting, intimidating wall of text. Let's move to and see how this builds into the interfaces we recognize today. Throughout the 1990s, a massive transformation started taking place. Linux evolved from that strict text-based terminal into a highly visual, accessible system. Desktop environments like KDE, which dropped in 1996, and GNOME in 1997, finally brought windows, icons, taskbars, and menus to the Linux ecosystem. This was a huge deal. It was the bridge connecting the immense power of the kernel with a user interface that mere mortals could actually navigate without tearing their hair out. Fast forward to today, and that visual journey has just completely transformed the experience. Modern desktop environments, like the ones running on incredibly sleek systems like Arch Linux, are gorgeous and highly customized. With smooth, modern display technologies like Wayland, Linux interfaces today are absolutely as sophisticated and user-friendly as any proprietary, expensive operating system you could buy off the shelf. But while the desktop was getting all pretty, Linux was quietly out there taking over the entire back end of the internet. By the late 90s, it totally dominated the server space, and this was largely thanks to a legendary open-source dream team known as the LAMP stack. It's basically a recipe for the web. Linux provided the rock-solid foundation, Apache served up the web pages, MySQL organized all the data, and PHP scripting brought the sites to life. This open-source combination delivered unparalleled stability, and it essentially built the modern internet exactly as we know it today. Now, for the average desktop user, the real turning point came in 2004. That's when Canonical released Ubuntu. Ubuntu completely changed the game by making Linux incredibly accessible, super friendly with different hardware, and vastly popular. And here is a fun, surprising historical detail for you. To actually get it into people's hands, Canonical used to literally mail free physical CDs to anyone in the world who asked. Isn't that crazy? This brilliant move caused its popularity to absolutely explode, proving once and for all that Linux wasn't just some niche tool for hardcore coders anymore. Remember that massive scale we discussed at the start of this explainer? Well, it all culminates in the mobile king. Billions of smartphones worldwide are running Android right now. And guess what? Android is built directly on top of the Linux kernel. That literally means billions of people are walking around with Linux technology in their pockets every single day. It is the world's most widely used mobile operating system, and the whole shebang stems from that flexible, open-source architecture Linus started as a student. And this brilliantly illustrates how Linux didn't just stay in one lane. It expanded to conquer incredibly diverse, specialized fields. In cybersecurity, distributions like Kali Linux are the absolute gold standard for transparent security auditing. In the gaming world, Valve completely revolutionized the space by releasing the Linux-based Steam Deck. And they use a technology called Proton that literally translates Windows games on the fly so they run perfectly on Linux. It's almost magic. And over in cloud computing, the digital shipping containers that keep modern apps running, technologies like Kubernetes, they rely entirely on Linux to function. It's wild to think about. What started as a solo student's hobby is now the largest collaborative software project in human history. Modern Linux kernels contain millions of lines of code. But what's truly remarkable here is the list of contributors. It's no longer just thousands of independent developers working on their own time. Tech giants like Intel, Google, and Meta are actively building it. And there's a profound irony here. Microsoft, a company that once famously called open source software a cancer, is now among the biggest contributors to the very kernel their own massive cloud infrastructures rely on today. Talk about a full circle moment. It's just a breathtaking journey, isn't it? From the ridiculously expensive, restricted systems of the 1980s to this open, secure, and flexible ecosystem that literally powers our entire world. So as we wrap up, I want to leave you with this provocative thought to ponder. If a single student's open source hobby could completely reshape the globe over 30 years, what will global collaboration build next? The future of community-driven code is absolutely limitless. Thanks so much for joining me today.